Hello everyone, guys, I'm Utkarsh and I welcome you all to this session on Python fundamentals for data tasks. So guys, let's have a look at the agenda for this session. The agenda for this session includes installing Anaconda and the Jupyter environment that are needed, let's say, to work on Python. Then moving forward, we are going to have an introduction to Python to understand what Python is all about. Then we'll look into the different aspects of Python as in learning the syntax and the core concepts, starting from variables, the different rules for naming the variable, the different data types in Python, and the different operators that we have in Python. So guys, I'm switching to the Jupyter screen. So guys, over here, we are into the Jupyter. Jupyter is one of the most commonly used Python IDEs. Now, when I talk about IDE, I simply refer to Integrated Development Environment. As in, an IDE is a platform onto which we can write Python code. So when we talk about the different IDEs for Python, we have IDEs like Jupyter, we have Colab, we have VS Code, we have PyCharm, and we have Spider. Now, the most commonly used Python IDE is Jupyter, and to install Jupyter, we need to have a software called Anaconda. So guys, this is the link from where we can download Anaconda installer from. So if I just click on this link, over here, you just need to mention your email address and click on submit. You'll find the link to download the Anaconda installer, and once the installer is available, once the, let's say, the exe is available, you just need to double click on it and just click on next and finish. I'll show you the installation steps as well. So to get through the installation steps, these are the different installation steps, right? So if I click over here, just have a look. What are the basic installation instructions? So you can download Python for Windows. You can download Anaconda for Windows, for Mac or Linux. So if I click on Windows installation, so first of all, you have to click on next to agree to the Anaconda terms of services. Then you need to select whether you want to install it just for yourself or for all users. So I would recommend go for just me. Then moving forward, you have to click on next, and then you have to let's say to select the destination folder, again you have to click on next, and then you have to customize the installation options, whether you want to create a shortcut, whether you want to add Anaconda 3 to the path environment variable. Then you have to register Anaconda as the default Python, whether you want to proceed with these options or not. Then you have to click on install. You have to click next twice, and then finish to finally close the installer. These are the installation steps. I can also show you, let's say, the screenshots for the same. So over here, I do have a link that displays the different screenshots, right? So once, let's say, the Anaconda is installed, you'll get the installer. The moment you click it, it will open up something like this. You have to click on next. Then you have to agree to the terms of service. Just click on I agree. Then you have to click on let's say install for just me and click on next. Then it will show you the default path that it will Anaconda will be installed. It will be routed to your C drive. So you can change it, but I would recommend, let's say, keep it C drive for the time being. Click on next. And then these are certain advanced options, whether you want to add Python to the path environment variable. I would recommend doing this. So just click on all the checkboxes and click on install. Then wait for the time being. And then you have to click on next and finally finish. So guys, once, let's say, the Anaconda is installed, right? Once the Anaconda is installed, you will find multiple IDEs in Python, multiple IDEs installed. Now, out of those IDEs, we need to use Jupyter. So in the search bar, you have to click Jupyter. What is Jupyter? Jupyter is an IDE that, let's say, is a web application as well. So it will open up in your default web browser. For instance, I'm using Firefox, so it has opened up in Firefox. If you're using Chrome, if you're using Opera, so it will open up in your default browser. All right. So I've shown the downloading steps and the installation steps. So moving forward, let's understand what are the different features of Python. So guys, Python is the most widely used programming language used in the world for, let's say, n number of varied applications, starting from data science to machine learning to AI to computer vision, to natural language processing, to generative AI, to even agentic AI and agentic AI workflows. Now, talking about the features of Python, Python is a high level language as it is, let's say, designed for humans to grasp, read and write. It is an interpreted language which simply indicates that the code gets executed line by line, and it follows object oriented programming concepts, utilizing which we can implement concepts such as class, object, inheritance, polymorphism, abstraction and encapsulation, and it is dynamically typed. डायनेमिकली टाइप्ड का मतलब ये होता है कि अगर हमने कोई लेट से वेरिएबल डिफाइन किया है, राइट, तो वेरिएबल का डेटा टाइप आपका रन टाइम पे डिसाइड होगा, implying कि suppose I'm creating a variable a is equal to 10. So at the runtime it is decided the kind of value that will be stored in the variable, not at the time of defining, because the data type can change. And over here we don't need to mention ki, let's say, what kind of value a variable can take. All right, and Python is case sensitive, implying that uppercase and lowercase, let's say, variables have different meanings, and Python has a very simple syntax which is quite convenient for learning, grasping and understanding. So guys, these are the common features or the characteristics that we have for Python. So moving forward, let's understand what are variables. So guys, suppose we want to store some data, right? We want our objective is to store some data. To store some data, we need to have some container. We need to have some container where we can store the data. This is where variable comes into picture. So variable can be defined as a container which is used to store some data, where the data can have any data type. Suppose I want to store someone's name, I want to store someone's age, I want to store his or her marks, maybe the school name, maybe I want to store the department onto which an employee works. So all these details we can store in a variable, or in fact in multiple variables as well. Now defining a variable in Python is very easy, it's quite convenient, and this is how and where we understand how to write code in Python. Now a variable can be reassigned, reinitialized and even redeclared. So first of all, let's start by creating a variable and storing some data. So over here I'm simply writing a is equal to 35. Now in this line, what is a? A is the variable. What is 35? 35 is the data or the value stored in the variable a. So how do we interpret this line? The interpretation over here is the value of 35 is stored in the variable a. This is the first implication. All right. Now the second meaning implied over here is the value of 35 is initialized in the variable a. Likewise, I can also say the variable a is assigned with the value of 35. Now the lines of code that I'm writing with hash in the beginning, these lines are referred to as comments. Why do we write comments? Comments are meant for internal documentation. They don't get executed. What is the purpose of creating comments in the first place? It is for the users to understand the code. All right, so I'll define what comments are. Comments, let's say, they are meant for internal documentation. Comments are meant for internal documentation. And how do we define comments? They don't get executed. How do we define them? Let's say they start with a hash. This is how we define a comment. I hope you are able to understand what comments are. So a is equal to 35. This line can be, let's say, discussed or understood in three different ways. The value of 35 is stored in the variable a. The value of 35 is initialized in the variable a, means this is just the initial value subject to further updates. Then we can also define it like this: variable a is assigned with the value of 35. All right. Now let's understand the second point, and we can also print this. I can also print this. So when I'm writing print, print is a statement, print is a function used in Python to print the value stored in the variable, or let's say to print some sentences. So print, because it's a function, so it is enclosed with round brackets or what we call as parenthesis. So when I'm writing a print a was initialized with the value of 35, so a gets displayed. So this rectangular box that you see over here, this is where we can write Python code. And to implement the code, let's say I've executed the code, I've written the code over here. To get this executed, I just need to press shift plus enter. I have to press shift plus enter. Alright, to get this executed, or alternatively I can press the run button over here. These are the two options that we have. Now, having understood how to, let's say, create a variable, let's understand what is meant by the term that variable can be reassigned, reinitialized, and even redeclared. So over here I've initialized the value of a with 35, right? Now what if I write a is equal to maybe 120 and I'm printing a again? So 120 gets printed over here. Alright, now this indicates that, see, I have reinitialized. This was the first initialization. This is the second initialization where I have initialized a with 120. This is called reinitialization. Why are we calling it redeclaration? Because the same variable a has been redeclared, or let's say rewritten over here. And have I reassigned the value? Yes. The initial value was 35. I've reassigned another value of 120 in the same variable a. Alright. So this is what is meant by that a variable can be reassigned, reinitialized, and even redeclared when it comes to Python. Now we can also, let's say, create multiple variables in the same line separated by comma. So how do we do this? I can write something like this: a1, a2, a3. These are the three variables, and in these three variables, first I'm writing Python, then I'm writing maybe 20, and then I'm writing maybe 7.8. So let's understand this. This simply indicates that a1 stores the value of Python, a2 stores the value of 20, and a3 stores the value of 7.8. We can print them like this: a1, a2, a3. Now 20 is without quotes, 7.8 is without quotes, but Python is with quotes. Why is it so? Because this is an integer data type, this is a float data type, however, but this is a string data type. Strings in Python needs to be enclosed in single, double, or triple quotes, and we'll discuss the data types as well in today's session itself. So now if I print this, to execute this, I can press the run button. As you can see, I get to see output a1 as to Python. a1 was storing the value of Python, then a2 stores 20, and a3 stores 7.8. So this is what I have printed over here. So guys, this is how we can utilize variables. Now variable do imply one more thing, which is worth mentioning over here. Means this is just to understand that variable is a container which is used to store some data, right? But on a technical level, what is the variable doing? Variable basically points to the memory address, all right, where the data is stored. So variable is pointing to the memory address where the data is stored. So in this example, if we see over here, a is pointing to the memory address where 35 is stored, and over here a is pointing to a different memory address, maybe where 120 is stored. All right, I hope this is clear. This point, that variable points to the memory address where the data is stored. Now having discussed let's say couple of points about variables, we also need to understand what are the different rules for naming a variable. As of now, I've simply named the variable as a, a1, a2, a3, but ideally we should provide meaningful name to the variables depending on the context into which we are using the variables. So what are the rules for naming a variable? It should start with capital A to Z, or underscore. All right, this is the first rule. What is the second rule? Should not start with a number. All right, should not contain special character or space in variable name. All right, and then we can say Python keywords should be avoided. Python keyword should be avoided as the variable names. So guys, these are the 4 rules. Variable name should start with capital A to Z, lowercase a to Z, or underscore. It should not start with a number. However, it can contain number in between or at the end. It should not contain any special characters or even space. Python keyword should be avoided as variable names. So what are some Python keywords? As in keywords like if, or, and, in, alright, maybe else, print, etc. These keywords should be avoided as maybe break, continue. They should be avoided as variable names. So every programming language has its own set of keywords. So in Python, these are the commonly used keywords. We should not use them as the variable names. So having understood these rules, let's try experimenting with few names, right? For example, over here I'm writing employee name is maybe Arpit Singh. Now, is this a proper variable name? If I were to print this employee name, is this a proper variable name? If it is, we won't get any error, but if it is not, we'll end up getting the error. Let's see. So over here we are getting the error. Which rule is it violating? It is violating the third rule. We cannot have any spaces or any special characters in between. To correct this, what can be done? We can simply write an underscore in between. Alright, now it's a proper variable name. Next, can we have another variable name? Let's say over here I'm writing something random like this, and I'm storing welcome. Is this a proper variable name? No. Again, this is not a proper variable name. Why? Because it is starting with a number. To correct this, maybe if this were the variable name, I can write it anywhere, but not in the beginning, right? After beginning, it can be written anywhere. So now it is a proper variable name. Now, is this a proper variable name? Yes, this is completely a valid variable name. Why? Because it is starting with capital A to Z or lowercase a to Z. Likewise, even this is a variable name. Suppose I want to store marks of a student, so I can store it like this. Why is it not violating any rule? Because it is starting with an underscore. So guys, these are the different variable names that we have to be mindful about while creating variables. So I hope the concept of variables and the rules for naming a variable is clear to everyone. Now, moving forward, we are going to understand the different data types that we have in Python. So as far as Python is concerned, we have some very basic data types that are used to store only single value at a time. Then we have a couple of advanced data types that are used to store multiple values in the same variable. So let's call this primary data types. So in primary data types, we can consider integer, then we have float, then we have boolean, then we have string, then we have none. Means these are the common ones. Then we have, let's say, collection based data types. Over here we have list, then we have tuple, then we have set, then we have dictionary. Means we do have more data types, but these are the most commonly used ones. So let's understand them one by one. So to display the type of a variable, we can use the type function. We have a function called type that is used to display the data type of a variable. So guys, we'll be creating variables one by one, right? In the variable n1, I'm storing the value of 45. So if I print n1 and if I print type of n1, see the data stored in n1 is 45. What is the type of n1? It is an integer. So what does integer stores? Integer can store any positive number, it can store any negative number, or it can even store 0. So I can pass a very large number, this would still be considered as an integer. Likewise, even negative, this is an integer, and even 0 is an integer, right? So currently maybe I'm using 45. So what is the data type of n1? N1 is an integer. Now let's talk about float. Float is a decimal number, right? Integer cannot, let's say, non-decimal numbers. When we talk about integer, we are considering only the non-decimal numbers. When we are talking about float, we are talking about decimal numbers, right? So decimal numbers, the data type which is used to hold the decimal numbers is referred to as float. Next, we can have Boolean value. So Boolean value can only contain two values. We do have, let's say, true and false. Over here I'm printing N3 and then I'm printing the type of N3. So guys, if you observe over here, Boolean can only store two values, true and false. We have to be mindful of the fact that let's say the first character of true is in caps and the first character of false is also in caps. Next, we have the most important data type, which is string. So if I were to store string, okay, let's talk about string. Now strings in Python, they are enclosed in single quotes, double quotes and even triple quotes. Now why do we use triple quotes? Triple quotes, we have these two options. All right, they are used to write multi-line strings. If I want to store strings in multiple lines, this is what I can utilize. So I'm creating a couple of variables like this. Let's say hello world. Now as you can see, I've used double quotes. If I use N5 over here, I'll be writing with single quotes. So in single quotes, let's say I'm writing welcome to Python. Now if I were to use multi-line strings, I would say Python, let's say, is utilized in data science, machine learning, artificial intelligence, it is utilized in data science, machine learning, artificial intelligence, generative AI, all right, agentic AI. And besides this, I can also write something else. So let's say computer vision. I can change the line over here, computer vision. Then generative AI and natural language processing. I am simply writing NLP. Now, as you can see, this is a line that I cannot incorporate in a single line. So I'm using multiple lines. Why is it used? Suppose I want to store paragraph kind of information, paragraph kind of data, then we need to use multi-line strings. So now if I print N4 and type of N4, I can print N5 and type of N5 and likewise N6 and type of N6. So they are all strings. As you can see, classes string, string and string. So this is how we can write strings in Python. Next, we have another data type, which is none. Why do we use none? None is used to define absence of any value. All right, so if I write type of N7, it will be none type. And if I print N7, so it is none. So guys, these are the commonly used data types. In the upcoming sessions, we'll look into these data types like let's say list, tuple, set and even dictionary. We'll have separate sessions on these topics. Now, having understood let's say the variables, the rules for naming a variable and the data types, it's imperative to understand the operators that we can apply onto these values. So this is where the concept of operators comes into picture. Using operators, we can apply different type of mathematical, logical, relational comparison operations onto the values stored in the variables. So the first operator that we are going to understand is arithmetic operators. So suppose I'm storing two values a and b that consist of 5 and 2. So if I want to apply mathematical or arithmetic operations, so over here I can simply perform operations like plus, minus, multiply, divide. Now it's pretty straightforward. A plus b, 5 plus 2 is 7, 5 minus 2 is 3, then 5 into 2 is 10 and 5 by 2 is 2.5. Now we have couple of other operations. A double forward slash b. Double forward slash indicates integer division. So its output will be integer if both the operands are integer. So 5 divided by 2 is 2.5, but the integer part of 2.5 is 2. So over here I'll be getting 2. Next I can write a double star b. What do we mean by double star? Double star is power operator. Power operator indicates a raised to power b. This simply indicates a raised to power b. This operation over here indicates a is being raised to the power of b. So 5 raised to power b is 25. Next, I can also write something like this, a mod b. This is the mod operator. What does it return? It returns remainder. So what will be the remainder when 5 is divided by 2? 5 when divided by 2 would yield the remainder as 1. So these are the commonly used arithmetic operators. These are the new operators, let's say, means these are the commonly used operators that we are all familiar with. Now these are a couple of other arithmetic operators that we should be familiar with. Integer division, power operator, and even mod operator. Now moving forward, we have assignment operators. So as the name sounds, it is used to assign values to the variable. So again, I'm writing a comma b as 5 comma 2. Now over here, if I write a comma b, I'm getting 5 comma 2. So the first assignment operator is equal to itself because it is assigning the values of 5 and 2 to the variables a and b. Now I can write something like this. What does this line indicate? Plus equal to is an assignment operator. What is the operation that it is performing? This is the kind of operation that it is performing. Now we have to understand this from right to left. So first we have to perform a plus b, which would be 5 plus 2 is 7. 7 would be stored in the variable a. This is how we have to interpret this. Are we changing the value of b? No, the value of b still remains unchanged. So a stores the value of 7, b stores the value of 2. Now I can also write like this, a minus equal to b. What is it going to return? A comma b. What am I getting? I'm getting 5 comma 2. Why? Because over here a is a minus b. The previous value of a was 7. 7 minus 2 is 5. So a stores 5. Likewise, I can write a equal to b, or maybe let me write b star is equal to a. What does this indicate? B is equal to b into a. So b multiplied by a, 5 into 2 would be 10. So now if I print a comma b, we'll get 5 comma 10. Likewise, I can also perform a, let's say, division equal to b. So what do we get in return? Over here I'm getting 0.5 comma 10, right? Because over here we are performing a by b, and the previous value of a was 5 and b was 10. So 5 by 10 is 0.5. Alright, so guys, all the, let's say, arithmetic operators that we have used can be used as an assignment operator as well. I've shown you a couple of examples on the same. Moving forward, we have relational or comparison operators. So they simply return true and false. What do they return? They return true or false. So let's see a couple of examples. I'm not, let's say, creating variables. I'm directly writing this. 5 greater than 7. What are we getting? False. Now if I write, let's say 7 greater than equal to 4, this would be true. Likewise, over here I can write maybe 3 less than 10. Over here I can simply write 8 less than equal to 8. 3 less than 10 is true. 8 less than equal to maybe 6. This is false. Now I can also write something like 11 double equal to 11. What does this indicate? Double equal to is comparison. Alright, basically we are asking a question. Is 11 equal to 11? Yes, that is true. But if over here, if I write something like this, 11 equal to 17, so I'll get false. So double equal to is comparison and single equal to is assignment. We have to be mindful of the same. Now, I can also write 12 not equal to 18. What is this operation? This is not equal to. Alright, so over here we are simply comparing, is 12 equal to 18? Is it the case? No, that is not the case, right? So it returns true. So guys, moving forward, next we have logical operators. In logical operators, essentially we use and or. Now and, let's say, what does it do? It returns true when both conditions are true and false otherwise false. And what about or? It returns true when any one of the conditions is true, otherwise false. So let's see some examples. Over here I'm defining a couple of variables a, b, c. Now over here if I check a greater than b and a less than c, a greater than b is false, a less than c is true. So overall the result is false because it requires both the conditions to be true. Now if I were to write, let's say b less than c and c greater than a, b less than c, 7 is less than 10 and 10 is greater than 5. So both the conditions are true. So the output is true. Now over here if I were to write, let's say b greater than equal to a or a greater than equal to c. Now over here can we say one of the conditions is true? Yes, b is greater than equal to a, right? Sorry. In this example, b greater than equal to a, b greater than equal to a is false and a greater than equal to c is also repeating. Guys, let's observe this example. B greater than equal to a, 7 is greater than equal to 5, right? So this is correct. And a greater than equal to c, 5 greater than equal to 10, this is incorrect. So overall the result is true because any one of the conditions is true. Now what if I make both the conditions false? B less than equal to a, this would be false, and a greater than equal to c, even this is false. So the overall result becomes false. So guys, this is how we can utilize the logical operators. Next we have membership operators that only works as of now on strings. Means let's say it can be applied to strings, list, tuple, alright, but cannot be applied on integer, float, boolean and none data types. I'm considering a string over here. The string is learning Python is fun, alright, and interesting. This is my string. Now in this string I'm checking the membership, whether a part of the string is it a member of the string or not. So how do we check this? Over here I'm writing is fun, fun in S, is fun a member of S? So I'm getting true. Why? Because it is a member in S. Now if I were to write let's say and, is and present in S? Yes, and is present, but as I just mentioned, Python is case sensitive, so uppercase and is not present in S, right? So I'm getting false. We can write something meaningless as well. So I can write something like on space I, on space I, is it present? Yes, on space I is present, so over here this should return me true. Likewise over here can I write let's say Python not in S. Not in S is just opposite. क्या Python S का member नहीं है? So over here I'm getting false. Over here I'm getting false, right? Because it is a member. On the other hand, if I write something like this, where not in S, so where is not present in S, right? So over here this returns me true. So guys, these are the different operators that we have in Python. So I'm switching to the PPT. So guys, this brings us to the end of this session. In today's session, we have discussed how to set up the Anaconda and the Jupyter environment. We have discussed the essentials of Python. We have covered how to use the different variables. We do have an understanding about the different data types that we have in Python and how to utilize the different operators in Python as well. Moving forward in the next session, we'll be covering conditionals, conditional statements, for loops. These are the topics that we'll be covering in the next session. Thank you.